Welcome to this Broadcom video on the ESP and AAI integration. This is the overview. The purpose of this video is to go over the components, processes, configurations, and system elements working together for AAI to source definition and event data from ESP. The integration requires some work in USS and a Broadcom framework type connector on a distributed system. The ESP integration requires deploying a number of components on the mainframe, developed and supported by the ESP product teams, including documentation and learning. The course offers an in-depth overview of the integration, but does not include a complete demo or full details for each step. Once the ESP components have been deployed, we explain the role of the connector. The ESP AAI integration requires the live data service on ZOS, the ESP adapter for AAI, the message service hub on USS, and the connector on a distributed system. Several items on the mainframe side, datasets, JCLs, and control members, assume various roles in requesting and delivering the data required by AAI. Your ESP service teams can help you deploy these items. The integration delivers definition data, meaning job, schedule, and event definitions, and event data, meaning executions, times, and status, to AAI, so it can build its own data. The integration also requires a connector installed on a dedicated host and the creation of a scheduler connection in the AAI Web UI. We acquire two data streams, definitions like jobs and scheduling, and events. AAI requests the data by ways of the connector. This means two-way communications between the systems. We start with definitions. ESP produces two reports, scheduled activity, generated with the SADGen and JobMap commands, and the job activity report, generated with the MapGen and again JobMap. SADGen generates a dataset based on a number of data points: job names, application names, triggering events, external jobs, and so forth. MapGen generates a dataset using definitions of jobs mapped to events. The data points include more things like agents, predecessors, successors, and more. In both cases, JobMap uses both datasets and converts them to the scheduled activity and the job activity reports. Together, these two reports form the complete set of definition data needed by AAI. The event data is created by an internal ESP component called Live Data Service, which outputs the live data feed, executions, execution times, and so forth. Live data is not enabled by default because the component is AAI specific. It needs to be activated in the ESP PARM dataset. Let's talk about some of the requirements. Several PTFs are required, and we recommend staying up to date on this particular topic, as presumably requirements will change over time and with each version. We need the live data service to be activated in ESP. This component produces the live data feed that is channeled into the various processes that produce the data needed by AAI. The entire acquisition sequence relies on three components. In USS, we need the ESP adapter for AAI, which is the MQ message producer. It's a started task initiated from the proc lib system. The live data service outputs messages to a live data feed called logstream, sourced by the adapter, which it translates into message queue type messages. The adapter must reside on the same LPAR as the ESP master. The second component, also in USS, is the message service hub, which is the distributor of MQ messages. It's based on the Apache ActiveMQ system. MQ messages are written into the hub by the adapter. The hub then distributes them to be exploited by one or more connectors that sit between ZOS and the AAI host. The message service hub does not need to reside on the same LPAR as ESP or the ESP adapter. It's an independent, autonomous system reached over TCP/IP. It's designed to support multiple masters, multiple adapters, and multiple AAI instances. The third component is the ESP connector, which is the MQ message consumer. It resides on a distributed system and is based on the Broadcom AAI connector framework technology. AI submits requests for definition data and the sequence is reversed. The connector requests data in the message queue format, which is submitted to the hub and passed on to the adapter. The adapter then submits the job to JES to generate the definition data from the log stream. Adapter and connector only support single connections. If you have multiple ESPs or multiple AAI servers receiving the data, then you'll need dedicated adapters and connectors for each. For example, whether it's one ESP and two AAIs, two ESPs and one AAI, or two ESPs and two AAIs, you'll need two adapters and two connectors. The Message Service Hub, on the other hand, can support multiple ESPs, multiple AAIs, and any combination of each. Let's describe the architecture. We start with three systems: ZOS, the AAI host, and the connector host. The ESP master server sits in ZOS, the connector on the connector host, and AAI on the AAI host. We activate Live Data Service, which starts capturing events and writes them to a DAS-D-only dataset called the log stream. Each time live data is written to log stream, the service updates another DAS-D dataset called the checkpoint, which tracks the date and time of that latest data delivery, so that we're able to execute a recovery in the event of downtime or connection failures. We have the ESP adapter for AAI component in USS. The adapter is Java-based code that sources raw log data from the log stream and converts it to MQ messages. The log stream has an ID called a token, added to the ESP adapter for AAI. This token identifies the data stream from that particular ESP master to guarantee data integrity throughout the connection chain between the adapter, log stream, and ESP master. The token is generally set to the ESP system name. The Message Service Hub, which is based on Apache ActiveMQ technology, distributes the MQ messages data to every single ESP connector throughout the broader environment. The connector is installed on a dedicated distributed system, either Unix or Windows, and has a name. The connector is configured in the AAI web interface with both the connector name, but also the ESP adapter token name. The connector registers itself with AAI, which means that data files it receives have both the token and connector name, and the chain is complete. The connection between the connector and Message Service Hub is defined in the web UI. Requests are initiated from the AAI host with the appropriate token, sent to the connector, pushed on to the Message Service Hub, and finally distributed to the adapter. In return, the adapter submits a simple job to Jess to acquire the data from the log stream and converts it to the MQ format. It sends both events data, called live data, and the definition data in the form of datasets, with the token appended to their names, to make sure the chain isn't broken. The ESP adapter requires a directory mounted as a volume in USS. We use it to cache the data before it can be translated into MQ-type messages and sent to the Message Service Hub, in the event the connection between the adapter and the Message Service Hub is temporarily severed. It should be sized based on data volumes and retention cycles. The same goes for the hub, so it can cache the instance data if the connection with the connector is down. This means we have three temporary data storage locations for catch-up purposes: the log stream, the adapter cache, and the hub instance storage. Finally, the hub's code is installed in a USS area called deploy. A JCL template called CYBIS005, member of CD7Y JCL, is provided for definition data. This is the JCL submitted by the ESP adapter to Jess to capture the log data from the log stream and translate into MQ-type messages for the Message Service Hub. You should duplicate this JCL and make adjustments based on your own environment and configuration. Specifically, the set statements need to be changed so as to reflect the reality of the ESP installation. Then it can be moved to USS. When the adapter received the request from the Message Service Hub, it will submit it to Jess for execution, wait for completion, convert the data to the MQ format, and then sends the result back to the hub. Thank you. This concludes the video.